morning. I will, this is my second presentation on this summit. I will be talking about getting Xen logs out of a system when you don't have real serial console available. So, yeah, this was already yesterday. So, why? Why do we need some other methods? I'm working on kexec. Our main target hardware is laptops, and nowadays laptops rarely have real serial console. If you are very lucky, you may found one on a docking station. There are some with real serial on a docking station. But otherwise, it's very rare. Even on desktops, it's more and more often to not have serial console. Usually, it's still somewhere. There may be some header on the main board or something, but yes, this is something that is disappearing from the hardware. And normally, when you have some problems, you can look into logs, but when Xen or DOM0 kernel panic, there is nothing that would save the logs. So we need some external way to extract them. Okay, so there are some methods to do that. So first of all, when debugging, there are some generic hints. Raise all the log levels. There are two options for that, for Xen itself and for guest-related logs. Then, if you are interested about DOM0 logs, you can redirect DOM0 console to Xen. So then pass console equals hvc0 to DOM0 kernel, and that requires Xen build with config verbose, if I remember correctly. Otherwise, those logs will be mostly ignored. And there is also early console from early console Linux console logging to Xen. There's another early print equals Xen. That's also helpful if you are interested about DOM0 logs. And of course, for debugging, use debug build. Okay, so first of all, the real serial console is still the most reliable way. So maybe there's a way to have that anyway. So in some cases, even on some laptops, it is there, but it's well hidden. It may be some not described connector on the main board. It may be some test points. Some of the laptops in the test setup I was presenting yesterday have something like this. So if you look into Linux messages, you will see TTY as something. And if you have it, then take a closer look at your main board. Maybe you will find it. Maybe there is some service manual with some more information, some description of specific test points. Sometimes it works. If not, maybe you can connect a PCI card, PCI Express card with serial ports. For desktops or servers, you have a lot of PCIe slots. That's easy. For laptops, you still have some PCIe slots. There is a mini PCIe slot for Wi-Fi or similar. There is M2 slot. And that is also a PCIe slot in most cases. This means if you use M2 slot, it means you probably will need something else for the disk, or maybe no disk at all and boot from, I don't know, USB or network. But still, there is an option to get a serial console this way. For both M2 and mini PCIe devices, when you are looking for something like this, be careful because both of those ports have not only PCIe, but also USB and few other interfaces. So just, especially with mini PCIe cards that claims to have extra USB ports, usually those are not really USB controllers, but USB hubs connecting, if you are the serial ports is not a serial controller, but it's a USB hub with USB to serial converters. Those will not work for getting serial. So this needs some more research what device specifically to buy. I have several those who are really USB to serial, but well, some are real serial controllers. So if you look closer, for example, here on this is serial port on MSI. This is 2-pin header. So there is only unidirectional console. There is only a transmit pin. But for getting messages out, it's enough. It's the description on the, it's not visible on this photo, but it's very enigmatic. It's not easy to guess, but if you look at the documentation, you can find it. But when you add to a laptop mini M2 card with a serial port, there may be some mechanical challenges how to expose this port. So here the laptop has some extra ports and some hole to access them. It works. This one is a card with, as you can see, with 4 ports. Regarding those cards, there are different ways to communicate with serial ports. If the card are using I/O ports, you can see that on LSPCI, then probably it will work with Xen out of the box. But if it's using MMIO, there is a table of supported devices in Xen, and it requires source code modification to add support. It's usually adding just vendor product ID with some basic information like the speed, the offset in the MMIO to access the registers and so on. It's usually enough to just copy and paste some of the existing entries, but it needs to be done to work. In theory, it's possible to give all the parameters from command line, but I haven't managed to make it work with any of MMIO-based consoles, so it was always required to make some source modification. So this is XR something card. It is already supported in Amsterdam. There was a patch for me to add it, but yeah, if you find some other device, you may need to add some support. Okay, so if not this way, then we have some more methods. There is USB 2 specifications have a debug port. This is a USB controller on a specific port. Gives an interface specifically for debugging. From the software point of view, it's very easy to use from the Xen. So Xen does support USB 2 debug port. But from the hardware point of view, it's tricky. First of all, it requires connection directly to the USB controller. There must be no hub in between to a specific port. You can look into LSPCI and Linux dmask to see which port number that must be, and hope that port will be available outside and it's not used to connect some internal devices. Again, on these desktops, that's usually easier. On laptops, there are several internal devices that are connected using USB, like camera or some NFC controller or fingerprint reader or any other devices. And it's common that they will use port number 1 on the controller with a hub, and it's also usual that this is the port that we would need for debugging. So yeah, in that case, we are allowed to flag. But if you have access to the port, then it requires just a special device or Linux USB gadget from, I don't know, Raspberry Pi or any other board like that, and connect it, and it should work with just one Xen command line option. There is some more useful information or coreboot wiki about that. Yeah, so that's one of the ways. But if you have USB 3, there is also debug capability. It works on a principle in similar way, but it's way more comfortable to use. First of all, it works on any USB-A, USB 3 capable port. So you are not, you don't longer need to find a very specific port that is used for some internal devices. Then you don't really need special hardware. You need USB A to A cable with some pins disconnected, specifically USB 2 data pins and power line, just for safety. It's in practice, those are pins that are on the edge of the port and not those internal. So it's enough to just tape over those pins in the plug. It works. It's very simple modification. So that's fine. And additionally, this is supported in Intel USB 3 controller. So most Intel, if not all current Intel devices simply support this out of the box. This is not the case with USB 2. With USB 2, in both cases, this is optional feature, but in USB 2, it's not very common. With USB 3, it's very common. There is one patch series that is necessary to get it working on the newer devices, because while the hardware is designed to operate this debug port independently of the main controller, it is designed for the different drivers to operate them, but not necessarily one from hypervisor and one from Linux. So if you want to share the USB controller with DOM0 for other ports, then some of the register may be on the same page as the debug registers. So there is a patch series to mark part of the page read only from DOM0 and not the whole page. But if you don't care about USB in DOM0 when you debug things, it's fine. You don't need any other patches. I hope I will get those patches finished and merged upstream soon. We'll see. Yeah, and in both cases, in USB 2 and USB 3, there is the DBGP parameter. I'm using here a very short version, but you can give it also more parameters specifically to set which USB controller to use. If you have multiple, then probably you want to use a specific one to which you connect the cable. There is no auto detection for that. Then, if you don't specify, then we'll use the first one it finds. And yeah. But for the USB 3, if you use, you can use any port, and it's the controller who will find to which port you connected this special cable. So that's nice. You don't need to configure which port to use. So there is also graphical output. It's not very convenient to use for panic messages because you cannot really copy and paste in this way. But if there's no other option, you can make it work, especially with boot crashes. Just use camera to record video and then find the right frame. There are some helpful options to do that. Sync console, no reboot to have some more time to capture it. And also, if you care about DOM0, if the crash happens when DOM0 is already running, so normally DOM0 take over VGA, and at that point you don't have Xen messages on the console. But you can use VGA equals something, comma, keep, to keep graphical console in Xen. DOM0 boot will be very slow in this case. But there maybe you will get crash message, which is much better than not getting this message. So maybe in some cases it helped me a lot. And then there is kexec. So this is I think the most complicated way to get messages because it requires a lot of setup. But you get not only messages, but also dump of the whole Xen memory. So maybe you can find some more information. You can attach, analyze the dump with some debugger and find what was going on. So the general idea is with kexec you replace the running or crashed hypervisor with some other kernel, usually Linux. And this Linux is loaded into reserved memory. On the boot of the original system, you specify how much memory you reserve for the crash kernel, and this area is not used for anything else. Then the crash kernel will be loaded in that area, but all the other, the whole RAM is still from the previous kernel, so it can simply dump it to whatever place you'd like. So, how to get it working? First, we need kexec tools built with Xen support. If your DOM0 is based on Fedora, then you need to rebuild kexec tools because Fedora ships the package with no Xen support. It's just a configure option, or it's automatically detected if you have Xen headers installed. Then you need Xen built with kexec support enabled. It's just kconfig option, nothing fancy. Then boot Xen with crash kernel equals some size. 256 max is enough for very simple case. On cubes we have full disk encryption, and 256 is not enough to open Lux device if we want to dump into encrypted partition. Right, you need a place where the dump will actually fit. So if you have a lot of memory, you need a lot of disk space. In theory, you could dump only like extract messages and only dump parts of that, but there are some issues. I will talk about that. And then finally load the panic kernel with kexec -p and options to specify kernel, the init RAM first with all the tools necessary to dump the dump memory and possibly extract messages, some command line parameters, etc. Whatever you like. So when you do that, when the Xen panic, it instead of rebooting or any other option, it will jump to this crash kernel. Okay, so how to prepare this kernel? So kernel itself can be just normal Linux build. It's useful for this to be rather small because you need to reserve memory for this kernel statically on the boot. So this is memory you will not be able to use for anything else. So it's probably better to keep it small. And then you need initramfs with tools necessary to dump everything. If you use Fedora, the kexec tools package include a kdump utility, kdumpctl, that is able to build initramfs using standard Dracut, which is a tool to build initramfs on Fedora, with also scripts to dump the memory of a crashed system. It is written with KVM in mind or generally with Linux in mind. So it needs a few modifications to get it working with Xen. First of all, the kdumpctl bash script, it assumes you will be dumping Linux. So there is a check dump feasibility function that check if crash kernel area is enabled in Linux. It doesn't check if it's enabled in Xen. So you basically need to disarm this function because otherwise it will fail before doing anything. Then if you want to use kdump service, so a startup script that automatically loads crash kernel, then in etc sysconfig kdump there is an option to kexec. You need to clear kexec args option because on Fedora it's configured to be compatible with secure boot, so it loads. There are two methods to load the crash kernel to Linux, but the one used by default with this package is not compatible with Xen. So yeah. And then finally in etc kdump.conf you set options where and how to dump the dump memory. So you provide a location, like file system path. You may provide some utility used to copy. It's basically a utility to copy proc VM core, if I remember correctly, to somewhere. So for dumping the whole memory, you simply set cp as the utility. If using crash kernel for Linux, there is a utility that is can do something smarter and not dump the whole area memory, but for example extract dmask as a kernel messages buffer, but it doesn't work for me with Xen. So we can dump the whole thing, and then you can analyze it. So the thing I found working, it's very ugly, but it works, is strings and grep. So if you have dump of, I don't know, 32 gigabytes of memory, then you run strings on that. It takes some time, and then you grab for your panic message. I recommend grep minus C, some large number, to get a context, and grep for a panic message. You will need to be a bit specific because if you grab just for panic message, you will find this panic message in text, text session of Linux kernel, Xen, and probably a few other copies if you are reading files with also some word. But if you grab for, I don't know, panic on CPU and some number, like regular expression, then it's usually enough. In theory, there is a crash utility that is supposed to extract, deal with this memory dump and extract messages, like looking at the actual where the actual location is based on the symbols in the in Xen. it did not work for me at all. Like it crashed or failed to recognize file format or something like that. But I've seen some related commits in April, I think, in staging. So maybe it's fixed already. I don't know. I would need to recheck. If that would work, it's much more convenient than strings and grep. But even if with strings and grep, it is working. I have a script with specific when debugging a specific bug to grep for specific area, and with 32 gigabytes of memory, it takes about 2 to 3 minutes to grab, but it's okay. Okay, so are there any questions? Does it work? The microphone? Okay. Okay.
One thing I'm just curious about on the VBA slide, you mentioned to use sync console. What effect has that had outside of Syria?
I've found it to make the console a bit slower to have a more reliable capture with a camera. I don't know. Maybe it was just a coincidence, but it made the capture a bit more reliable with my very potato camera.
Okay. And, the other thing regarding the commits you were talking about, I think they were accompanied. You're talking about the Xen side commits. I think they were accompanied by a couple of changes also in the crash utility.
Okay.
So if you look for how this would fit together, you may want to talk to Jürgen, who did all that work, and know what was done on the other side, or you may just want to check what happened on the crash side.
Okay. Yeah, because I tried to use it, but it didn't work. I was talking with Jürgen, I think, last year, and
I mean, this appears to be a constant issue. We changed something in Xen, and the crash utility doesn't keep up and breaks.
Okay, thanks. Other questions? Okay, thanks.